Hello? OK. So my name is Bartłomiej Witczak. I'm a software engineer. And today I would like to tell you a bit about React and Flux. So to begin, I need to say that about a year ago, I was moved to another department to take over the project. It was a backend Java. And on the front end, there was a Dojo framework. The decision was made to maintain the backend and add features, but to create the front end from scratch. There were no decisions what architecture, what frameworks we need to use, so we get like freehand. There were no tests for current front end. It was not maintainable at all. So I will give you a bit of background for the application. So first of all, this is an internal tool. We need to deal with the big map inside our screen. And in the panels, we have some information. So some information pops up in the left panel. Some information pops up in the bottom. Something is changing, some counters. So although the application is not very complex, it is very rich in user interface. And we are dealing with sharing state between multiple components. And as I said the previous version was not maintainable at all. So it was really important to make our application easy to extend, to add features. OK, I don't know what the state of JavaScript here is, but I need to tell you that there are a bunch of test frameworks. We had a lot of testing libraries. We have some transpilers from JSX, from SAS, from ECMAScript 6 to the previous one. Of course, we got a bunch of frameworks: Angular, Ember, Backbone, React, to name just a few. And of course, everything is based on the node. That's how the JavaScript ecosystem looks like. You can say it's crazy, you can say it's funny, you can say it's immature, but in my opinion, it's a mix of all of those stuff. So today, I would like to focus on two things. I will talk mainly about the Flux, and I will talk a bit about React, because I'm using React as a view layer of my architecture. So let's get started with the React. When we enter the homepage, we see that this is the library for building user interface. And in my opinion, this is the most complete definition. Because there are many comparisons in the web between React, Angular, React Ember, and many others. And since they are valid, React is only for the view layer. It does not impose any architecture, the code-base structure. It has no dependency injection mechanism inside it. This is just the pure view layer. And that's why I think it's so popular nowadays. To give you just the taste of the React, everything is based on the components. So we have the most simple component here. It's rendering every time the same thing, every time static markdown. As you can see, of course, it's not using the pure JavaScript, because that's how our ecosystem works. It's JSX. But of course, if you would like, we can use pure JavaScript to render our elements. The JSX was created to make this work a bit more convenient. When we think about React, the first thing that pops up is virtual DOM. We all know that the current DOM was not created in mind to create very rich and dynamic UI. It was created rather to make some static pages. And that's why Facebook came up with the virtual DOM. So the abstraction of a DOM kept in memory. And whenever we are creating our components, whenever we are changing our components, it has diff algorithm to see what changes you need to make and makes those transition batches. So you can say that updates are more efficient. And that moves to boosting performance. And of course, that's the fact that it's really fast. But I think that that's not about performance, and that's not about DOM only, because there's a bit something more. So whenever we are building our application, we are building as small components, as tiny ones as we can. We create components to make only one thing. Then we compose our application of multiple components. And building application in this manner helps us to use our software engineering practices. Another thing is that we are trying to make data flow unidirectional. So we are trying to go from outer to inner. Only the outer elements, our outer components, are aware of state. The inner components shouldn't be aware of state. They should only be a function from the data to the markup. OK, now let's move to the architecture. So we all know kind of MVC architecture, call it MVC, MVVM, MVP, whatever. We have some action, we have some controller, and the most important, model view binded in two-way. And this works really good. It works really good if our application is tiny and we do not have many components that has the same state. But what happens when we add more and more views, more and more models? You cannot tell me directly if we have here some infinite loop, because some model can update some view, then view update another model, and update another view. And it's really hard to scale. That's why we have Flux architecture. So it consists of 4 elements. We have an action, we have a dispatcher, we have a store, and we have a model. All of those elements are connected in unidirectional data flow. So it could go from the action, through the dispatcher, to the store, and to the views. Views also can initiate some actions. So let's go one by one to see what are the roles of those. So we have action and action creators, because action is something similar to event. It has some type, and it has some data associated with it. We also need some action helpers because we would like to make our method more semantic, so something like big talks, not to just push data and push events by ourselves. Next is dispatcher. And this is the piece that broadcasts all actions. Any store can listen to the dispatcher actions. It is similar to event emitter, and all actions should go through this dispatcher. It is really important to know that there is only one dispatcher for the whole application. As I said, it's similar to event dispatcher, and to prove it, this is an API for the dispatcher. So we have some dispatch action, which is similar to the emit action. It has some register and unregister functions, which are going to be used by our stores. And there is one more wait for method, if you would like to make our store more sequential. OK, let's move on to the store, because the store is the heart of our application. This is the place where the business logic lives. This is the place where we can validate data, we can calculate new state, we can make some calls to the backend. This is also important that store manages state itself. It does not expose any setters on the outside world. It does not expose any business logic to the outside world. Everything is managing by itself. The difference between Flux and MVC is also that inside Flux, store is the place of truth. So whenever we would like to know what the state of our application is, we need to look to the store. And this is our place of truth. This also enables us to reason about our application more easy. The last piece is the view. And this is the place where the React lives. The view components should be as stateless as possible. As I said earlier, only the outer elements should be aware of state. OK. Now let's talk a bit about code base. Some says that we could structure our application in that manner. So we have some directory for actions, some directory for stores, some directories for views. But I think this doesn't scale, and for bigger application, it's not working. That's why what I propose is to divide our application in modules. We have, let's say, some talk modules, some schedule modules, and each module, each directory contains all actions, store, or views. I said earlier that there is a problem because we do not know if there is infinite loop. We have a lot of dependencies between components. And I said that Flux is going to help us. But as I think, those two doesn't match because we have a lot more views in the MVC. So it looks a bit more like this. And you can say, OK, because we have much more dependencies. And of course, it's a fact. But you can also see that there is unidirectional data flow. So all the time, we can reason about our application. We have store, which is the place of truth. And it helps us a lot. OK, let's go for some coding. We are going to create a really simple application with only one button, which is going to populate with talks. So let's start with the first component. We have some outer component, which is going to present our button. We need some action pick talks. If you could see on the diagram, we are in this place. We are creating view component, which is going to make some action. Okay. We need some imports, and we're done with the first component. Now, since we are in the view is making action on click. We need to make some changes, some stuff in action. So the first thing we would like to create in the action is some constant. We are going to dispatch actions, and we do not want to mess with the just strings, so we are creating some constant for those actions. Next thing is our utility functions. We are going to pick talks. So as you have seen in our view component, we are using the semantic method pick talks. And that's why we are creating the action pick talk. This action is only dispatching event of the type we have created in our constants. Okay. Now we need some import because we are going to use the dispatcher from the slide. The last thing we need to do in our actions is to export functionality we are going to use in our application. We are exporting the create method because I'm using the factory pattern to make my components more testable. Of course, we are exporting the actions, so the singleton we are going to use in application, and also events, because store are going to listen for our events. When we are done with this, we move to the dispatcher. And dispatcher is the place where we are using the library. So although the Flux is a notion of architecture, it is also one of the Facebook library. And we are using the dispatcher. As you can see, here we are exporting dispatcher, and it's going to be the only instance of dispatcher for our whole application. So we are done with action, which has dispatched the action. We move to the dispatcher. And now let's move to the heart of our application, so to the store. As previously, we are starting with defining some constant. We are going to use pick-talk actions from the actions file, and we are going to create some event that the state of the store has changed. Next, we are going to use to define the handler. So we need to define what actually is going to run when our action is dispatched. So here, as you can see, we are taking the data from JSON, but here we could make any validation, calculation, or some HTTP request. After that, we are emitting event that the state of our store has changed. Now the store itself. As you can see, the store is an instance of event emitter. Because whenever the state of the store is changing, it's emitting event that the state has changed. We are going to use view components to register for our store changes. And of course, we are registering for some action from the dispatcher. Last thing is that we are providing the state of a talks, and initially it's just an empty array. Okay, of course, for this to work, we need to define some imports. So we need also dispatcher. We, of course, need event emitter. And at last, we need to export something. We are going to export, as previously, the create function if you would like to test our store, the store itself for our application, and also events because we'll need them for our view components. OK, we are done with the store, so let's move on to the views. As I've told you, when we are building the application made of React, we are trying to make as small components as possible and to compose them into another component and another and another. That's why here I'm going to create two components. The first one is going to be the list, which is going to display every talk available. But this list is made of small components, so the talk components. So first, let's go and create talk component. And the component is really simple. As you can see, we are creating something similar to what I've shown you at the beginning of presentation. So we are implementing the only required function, the render function, which is going to tell what markup we are going to render. Here, I am using the props property, because when we are creating the talk component, we need to somehow pass data to it. So we are going to use the props property of the React. As I've said, those small components should be just the function of data to the markup. And this is exactly how it's working here. We are using the props property to pass data. This component has no state, it just renders it. OK, now we can move back to our list. OK, we need some imports, because we are going to use the talk component that we have just defined. And we, of course, are going to use talk store, because this component is the one which is aware of state and is going to listen for the store changes. Now, let's implement render function. So this is the function that is going to give our markup. We are going to use the talk component. This is exactly the place where we are using the talk component. This list has state, and inside state, it has many talks. For each talk, we are going to create one small talk component. And creating this component, we are using this talk props, and we are passing the talk from the state. Then we are just rendering. So the last bit that we need to make here is to make this component aware of the state. And this is exactly what we are going to do here. So inside talk component, I have passed only props. And props is something that we are passing to component, and this cannot change. If we would like to change the state of our component, we need to make some state property. We are going to initially make our talks empty, because this is how the store is at the beginning, as you have seen. Then it's a very important lifecycle method, which is component.mount. So whenever we create the list, we are making it aware that whenever the store has emitted change event, it's going to update this state. So whenever we change the state of our store, it's going to emit event, then view is going to listen for this event, and it's going to change the state. Changing the state is running the render function, and it's looking what DOM changes it needs to make. So this is exactly what we need to do. OK? Last component is our main component, because, of course, here we also need to add our talks, our list component, here made talks. OK. Let's run our demo. OK. So we have our application. It has a button, and it has a list. At the beginning, initially, our talks array is empty, so it should not render anything. Whenever we are pressing the button, we are emitting the action. It's pick talk actions. The store is updated. Whenever store is updated, there is an event emitted that the store has changed, and the view needs to change. OK. So that's how the pieces are connected. You can say it's nice, but are there any flaws? Of course, as all solutions, it also has some disadvantages. First of all, as you can see, there are quite a few elements we need to create. There is an actions element, store, views. Everything is connected. But still, there is a lot of boilerplate we need to write. Another thing is that some say that testing is really hard, but in my opinion, using the factory pattern really helps us with testing our actions, our store, and of course, our components will be easily testable. What I would like you to take away from this presentation is that both React and Flux supports unidirectional data flow. It really helps us, it really simplifies how we are going to reason about our application, and it really helps us to add new features and add more people to our project. Okay, so that's all from my side. Thank you very much, and if you have any questions.
Thank you. We have a couple questions from the audience. The first one, what do you think about function components in React? Do you use them?
Okay, so I haven't used them. We are using the approach I've presented here. So we are also not using the classes from the ECMAScript 6. And I think that this approach is really nice.
Okay. And the last one, why did you choose Flux over Redux?
So when we were beginning almost more than a year ago, the Redux was not so popular. Redux is different in the sense that it's using only one store for the whole application. And since our application is going to grow, I think that having only one store for the whole application and keeping state in only one store is not suitable for our case. But I think that Redux is solving a lot of problems we have with the Flux approach because it requires much less boilerplate code.
Okay, thank you very much. Give a round of applause for our speaker.
Thank you.